Okay.
So we're going to start with inhalation first. So let's fill out this box down here. And it's a little bit confusing because the and again, you can't see it on the model, but in us, the diaphragm domes up. Okay. Yeah. Yes. Okay. So the resting spot of the diaphragm is kind of domed into the thoracic cavity. Okay. When you contract muscles, right? Okay, that forms the inhalation. Okay. So you guys remember which muscles are for inhalation?
It's abdominal diaphragm.
Helps.
Inhalation, that's the force. Let's just do regular without being forced anything. It's going to be the diaphragm, right?
Just regular is diaphragm.
Diaphragm plays a big role, but also the external intercostal muscles are also inhalation muscles at rest. Okay, resting. Pectoralis minor, there's some other ones in there too during forced inhalation, the maximum amount. We're doing just the rest. Okay, so this first column here, right above it, okay, this is going to be inhalation and exhalation. The first column, inhalation, steps, and the second column, exhalation. So we're going to answer these, and this is going to tell us the volume and pressure relationship as we go. Okay, so during inhalation, there's just like the cardiovascular centers in the medulla, the respiratory centers there too, and so it's going to send signals to the diaphragm called the phrenic nerve, okay? And that's going to cause the diaphragm to contract and change shape. So basically, it's going to do this. Okay. Yes. Okay. So what's that going to do to the cavity up here? So what's the first question? Volume of air in the bell jar. So if the cavity's larger, then the volume of air, right, is going to increase because this is inhalation. Now we're going to see why. So as the diaphragm contracts and the external intercostals, okay, that in general makes the thoracic cavity larger volume. What happens to pressure if the volume is larger? Pressure goes down because more space, right, for the gas molecules to bounce around. So volume and pressure always have an opposite, right, relationship. Okay? So the volume of air in the bell jar is going to increase. Okay? Pressure increases. And really, it's probably better to say the volume of the thoracic cavity increases with the diaphragm contracting. Okay? Which means that pressure decreases. Now, because of that, pressure is higher in the outside. They call it atmospheric pressure. Than in the inside, in the lungs. That's why these balloons representing the lungs are going to fill, because diaphragm contracts, thoracic cavity volume increases, pressure decreases, and you get that air coming in, right? It's leaking a little bit. That's why I didn't have They should inflate, yeah. Which it was doing, but I think there's a problem.
They're inflating a little bit.
Yeah.
Problems like that.
There you go. Okay, and that's because the volume, right, larger, pressure fell, and air has a gradient just like the blood had a pressure gradient.
The air is rushing into the lungs.
Yes. So you have to have inspiratory or inhalation muscles contract, making the volume of the thoracic cavity larger in order to make the pressure lower, in order to get air in.
Okay.
So balloon size is inflated, and the direction of airflow is into. Go. So those are the inhalation steps. Now the opposite, as long as you're not forcefully exhaling air, right, you don't have to contract any muscles at rest. So when you're just listening to me, right, inhaling and exhaling, the diaphragm, after it contracted, right, for inhalation, when it relaxes, where does it go? It goes back up, right? So it goes back up. What happens to the balloons? Air went out, and why was that? What happened to the volume when the diaphragm relaxed? Volume decreased based on what it was, right?
Yeah.
Which meant pressure does what? Increase. Now pressure is highest in the lungs, lowest in the atmosphere. That forces air out. So that's why the balloons deflated, because they were inflated, right? Okay. And the diaphragm was contracted, right? Now they relaxes, goes back up to its original, right, location. Air went out because the pressure increased. based on what it was before. Because during inhalation, right, air came in, right, so you had much more volume inside the lungs than you had before. So those are the steps, and that same thing's going to happen, right? So when you were going through, when you review these muscles later, okay, the external intercostal muscles and the diaphragm, those are active during resting inhalation. That's what makes your cavity larger, your thoracic cavity. When they relax, that bounce back is what causes the exhalation. But as soon as you want to forcefully inhale or forcefully exhale, that's when other groups of muscles are involved. So if you want to forcefully inhale more air than at rest, you have to not only contract the diaphragm, but the external intercostals, the scalenes, the pectoralis minor. You have to contract other groups of muscles, mainly that expand the rib cage, making the cavity even larger.
So
if you exhale, if you forcefully exhale, the abdominal muscles shoot up a little bit towards the thoracic cavity, increasing the pressure even more because you're decreasing the volume, getting more air out.
So the intercostals would be more.
So you feel your abdominal muscles contracting when you forcefully exhale air out more than usual, right?
Yeah.
You have to contract them in order to push more air out. Just like you have to contract additional muscles like the pectoralis minor around the ribs to get more air in. So it's all about which muscle groups are active or relaxed that changes the volume of the cavity and therefore changes the pressure.
Okay.
Does that make sense?
And
we're going to talk about when we get to the respiratory system. Yes. So for these muscles, all the muscles that are listed, these are all visible on the muscle models. So label the figure, but make sure you're looking at them on the muscle models because that's what I'm going to ask them. Okay? And then divide them into inhalation and exhalation muscles. Like we said, external intercostals and the diaphragm, those are inhalation. Those are at rest inhalation. There's a few other muscles that are forced inhalation, but they're still for inhalation. Okay. And then which muscles allow for forced exhalation? The abdominal muscles, for example. So you can make yourself, and which they're getting at indirectly. See, it says effect on thoracic dimensions. So if you're increasing the area or decreasing the area, muscle groups that increase the area are going to allow for more inhalation. Muscle groups that decrease the area.
Increase or decrease. We have to.
Diameter, right, is still volume, right? Diameter is just the little march all the way across.
Okay.
Larger diameter means more volume. Smaller diameter means smaller volume. So the external intercostals, when they contract, they're inhalation muscles. They increase the diameter, right? They expand the thoracic cavity.
Yeah, but here we have to write down because here they only are.
Yeah, but this is going to tell you whether they are inhalation, exhalation. Any muscles that expand the thoracic cavity are for inhalation, decreasing the volume and pressure, or increasing the volume, decreasing the pressure, bringing more air
like
in.
It says here, like elevate ribs.
External intercostals are around the ribs. So when they elevate the ribs, that expands the volume or diameter of the thoracic cavity, promoting inhalation. So any muscle groups that expand the thoracic cavity are going to be your inhalation muscles. Any muscles that decrease the diameter or volume of the thoracic cavity are going to be exhalation muscles.
Yeah, but we cannot use those for exhale.
No, external intercostals
Because
are
we
only
don't have
inhale.
control, or is because of that?
No, there are still nerves being sent from your medulla activating the external. So external and